Hello everyone, my name is Waqas Saeed. Today I will tell you practically how to convert a 2-wire analog signal to 4-wire analog signal in Yokogawa CENTUM VP DCS system. My main purpose in making this video is to help two types of people. 1. Who is installing an analog card first time in the CENTUM VP DCS system. 2. Who has already installed analog card and they had some changing of an instrument in their field side and the field instrument is changed from 2-wire to 4-wire. The Yokogawa analog card which we see in detail is AAI143. And the main content or topic which we cover today includes the following points. 1. We will see the video in which I will show practically how to change any 2-wire signal to a 4-wire signal. 2. How can we detect the signal type in the auxiliary cabinet wire TBs? 3. We will see the wiring scheme of the 4-wire signals 4. And at the end of the video, we will see the characteristics of the AAI143 card. So starting with the first content of the video, that is how to convert 2-wire analog signals to 4-wire analog signal by changing the jumper given on the analog card. As you are seeing the front view of the analog card. CN1 is the point where a terminal connection or a terminal block is used to connect the card with field devices. And a black status LCD is given on the top front, where you can see the status of the card. So when you flip the card, you can see that there are 16 green color jumpers present on the card, 8 jumpers are present on upper cutting, and 8 jumpers are present on lower cutting. Each channel had an individual jumper. The sequence of the jumper according to the channel number is given on the card. As you can see, the channel 1 to 4 is given on one side and their sequence numbering is mentioned below. Similarly, channel 5 to 8 jumper is on the right side of channel 1 to 4. Also, you can see that their sequence number is mentioned below on the card. The same sequence is given for the lower cutting where the jumper of channels 9 to 16 is present. In between the channel sequence, you can see that jumper position is mentioned. That how can you put the jumper on the terminal to convert the signal from 2-wire to 4-wire. As all the channels are isolated from each other in I143, so that's why you can shift any signal from 2 wires to 4 wires. Now I will change some of the channel jumpers to show you a practical illustration of how can we change these jumpers. In this video, you are seeing that I had already shifted my first signal to a 4-wire signal jumper terminal. And I put out the random jumper for better describing you, by putting back jumpers to the 4-wire terminal points. So I put out the jumper of channel 3, channel 6, channel 7, channel 10, channel 11, channel 14, and channel 15. Now I put the jumper according to the 4-wire signal one by one starting from channel 6. Then channel 7. Then channel 3. Then channel 10. Then channel 14. Then channel 11. And in the last, we set the jumper of channel 15. I think you can understand easily how to convert the 2-wire signal to a 4-wire signal. There are no special changes required on the software side, but you will require some changes on the terminal wiring side. I will explain this as we move further in the video in the wiring section content.
So moving to the next content of the video, that is how to detect the signal type in the auxiliary cabinet. It means that you can detect signals in an auxiliary cabinet by measuring the voltages on the terminal blocks. Also, you can learn the wiring scheme of 2-wire and 4-wire transmitters in this video. Starting from the analog card AAI143. As you are seeing that this analog card had a terminal connection point CN1 with terminal pins on the front of the card. On CN1, three different types of terminal connectors can be used. We are using here the terminal connector ATA4S00. To clarify your concept of wiring on the terminal connector, let me show you the picture of the card with wiring we had in our Yokogawa panel. In this picture, you are seeing two analog cards on which wiring is done on their terminal connector. Now let's see the wiring scheme in the auxiliary cabinet, where we had to do wiring on fused and unfused terminal block for every signal channel. As you are seeing that I had taken the picture of the analog card present in the auxiliary cabinet. As it is 16-channel analog card, we had used 16 fused terminals and 16 unfused terminal blocks. The wiring which is done in the auxiliary cabinet on the terminal blocks has two sides. The wiring which is done on the left side of a terminal block is the wiring which is coming from the terminal connector of the analog card coming from the control panel. On the right side of the fused and unfused terminal block of the auxiliary cabinet, which is free at the moment, is used for the field side termination of the signals. The detail of the wiring on the connector of the analog card is given on the picture, with the name description of the wiring. As it is 16-channel isolated card, so the terminal connector wiring point of every signal is given with A and B point, where A1 and B1 is the termination point for channel 1 of the analog card. Similarly, A2 and B2 are the termination point for channel 2 of the analog card. Up to A16 to B16 termination point, which is for channel 16 of the analog card. The wiring scheme in the auxiliary cabinet from the analog card terminal connector is given as follows, channels wise, as you are seeing in the animation. We use fused and unfused terminal blocks for every signal and their sequence is highlighted on every channel. I think you had now understood about the wiring of the analog card up to the auxiliary cabinet terminal block. Now let's take an example for a better understanding of wiring in the auxiliary cabinet from the field side. Let's suppose we had 4 numbers of 2-wire transmitters. Now we choose random 4 channels with fused and unfused terminals for wiring these 2-wire transmitters. Let's suppose we choose channel number 2, channel number 0.5, channel number 0.10, and channel number 0.14 to connect these 2-wire transmitters. So before wiring these transmitters in the auxiliary cabinet on the field side, the first thing we need to do is to measure the voltage on the fused and the unfused TBs with the multimeter. When we connect the multimeter knob with the fused and unfused TBs, we see that 24 volts DC is coming on the multimeter, which means that signal points are active and okay for termination on the field side from the analog card. We will then move the multimeter to the next point for measuring the voltage that is on channel number 0.5. If we see the 24 volts DC coming on the multimeter on channel number 0.5, it means that signal points are okay. Also, we terminated our first transmitter on channel number 0.2 in such a way that input positive of the channel is terminated on the fused TBs and input negative is terminated on the unfused TBs. Then we will move the multimeter to the next point for measuring the voltage, that is on channel number 10. Again, if we see the 24 volts DC coming on the multimeter, it means that signal points of channel number 10 are okay. Also, we terminated our second transmitter on channel number 5 in such a way that input positive of the channel is terminated on the fused TBs and input negative is terminated on the unfused TBs. And in the last, we will move the multimeter to our last selected point for measuring the voltage that is on channel number 14. Again, if we see the 24 volts DC coming on the multimeter, it means that our last selected signal point, channel number 14, is okay. Also, we terminated our third transmitter on channel number 10 with the same practice of termination, that is, input positive of the channel is terminated on the fused TBs and the input negative is terminated on the unfused TBs. So in the last, we move the multimeter aside, and we terminate our final transmitter on the last selected channel, that is, channel number 14, with the same practice of termination, that is, input positive of the channel is terminated on the fused TBs, and the input negative is terminated on the unfused TBs. So, I think seeing the above example, I think your concept is clear on how to terminate the two-wire transmitter on Yokogawa CENTUM VP analog card. Now we move to another scenario. Let's suppose all the 4 transmitters in the field side are changed from 2-wire to 4-wire transmitters. In this case, the first thing we do is that we will change the jumper given on the analog card from a 2-wire to 4-wire jumper setting, as I had explained in detail at the start of the video. So, before wiring the transmitter in the auxiliary cabinet on the field side, we will repeat the same procedure as we had already done. That is, what we need to do is to measure the voltage on the fuse and the unfused TBs with the multimeter. When we put the multimeter knob on the fuse and unfused TBs, we see that 0 volts DC is coming on the multimeter, which means that signal points are passive and okay for termination on the field side from the analog card. We will then move the multimeter to the next point for measuring the voltage, that is, on channel number 5. If we see the 0 volts coming on the multimeter, it means that signal points are okay. Also, we terminated our first transmitter on channel number 2 in such a way that the input negative of the channel is terminated on the fused TBs and input positive is terminated on the unfused TBs. This is very important thing, and the main concept of 4-wire transmitter termination is that we will reverse the wiring scheme during termination as we do for the 2-wire signal. Also, you are seeing that the transmitter is taking power from the power supply externally. Then, we will move the multimeter to the next point for measuring the voltage, that is on channel number 10. Again, if we see the 0 volts coming on the multimeter, it means that signal points of channel number 10 are okay. Also, we terminated our second transmitter on channel number 5 in such a way that the input negative of the channel is terminated on the fused TBs and input positive is terminated on the unfused TBs. And the transmitter is taking power from the power supply externally. And in the last, we will move the multimeter to our last selected point for measuring the voltage, that is on channel number 14. Again, if we see the 0 volts coming on the multimeter, it means that our last selected signal point, channel number 14, is okay. Also, we terminated our third transmitter on channel number 10 with the same practice of termination, that is, input negative of the channel is terminated on the fused TBs and the input positive is terminated on the unfused TBs. So in the last, we move the multimeter aside, and we terminate our final transmitter on the last selected channel, that is channel number 14, with the same practice of termination, that is, input negative of the channel is terminated on the fused TBs. And the input positive is terminated on the unfused TBs. And the transmitter is taking power from the power supply externally. I think your concept for wiring of 4-wire transmitter and 2-wire transmitter is cleared. And also, it is clear that if you don't want to pull out the card from the cage, and want to know whether your channel is passive or active, you can check it by using a multimeter. If the multimeter shows some voltages on the fused and unfused TBs, it means that you had an active channel from the DCS side, and you can use this channel for a 2-wire signal. And if the multimeter shows 0 voltages on the fused and unfused TBs, it means that you had a passive channel from the DCS side, and you can use this channel for a 4-wire signal. So moving toward the concluding part of the video, let us see some of the characteristics of the analog card. AAI143. Firstly, it is a 16-channel isolated card. But if the module is used in an intrinsically safe application, you must use a safety barrier with this card. Secondly, its input signals are 4 to 20 mA. These signals can be used for 2-wire signal loop, as well as a 4-wire signal loop, depending upon your field instrument's requirements. Thirdly, this analog card can be used as a single, or in a redundant configuration in the Yokogawa CENTUM VP system. Fourthly, this card is also available with digital HART protocol communication. As you are seeing in the suffix code, if you select suffix code as H, then our card support digital HART communication. And lastly, 3 types of a connector can be used on this analog card. One is a pressure clamp terminal block, for isolated analog signal. Second is a connector cover for mil cable. And last is KS cable interface adapter. Thank you for watching my video. I hope that you like the content of the video. Put your views in the comment box and suggest to me the content you want, and also guide me on how can I improve my channel. Your comments and suggestions are very valuable to me. You can also contact me directly via my given WhatsApp number. Will like to see you in the next video, inshallah.